All right, cool kids. As soon as you saw in homework, I think it was the last section or second to last section. What was it? Where was it?
Second to last section.
Okay. When it said use synthetic division, hopefully right away you guys were like, well, I know I'm doing a box, and I of 2, 0. Oh, did you do 0? With a plus. What's the only possible number that could go in the box? 1. Why not negative 1? Yeah, your factor that you'd be dividing by is x minus 1, but your 0, which is who you plug in the box, is x equals 1. You're just plugging 1 straight in. Some of you might have messed that up a little bit in homework. How do we do synthetic division? You tell me. I'm a puppet. I don't know what to do. I don't know math. Put the product under the 0. Nice terminology. What about the negative 2? Oh, because we're supposed to be finding the function value. What's the remainder theorem say? Whoever the is the same thing as the, how do you verify? Interesting, muy interesante. Did that make sense? How many of you guys think that the group work helped your understanding of this go a little bit deeper? Okay, at least a couple. At least a couple. How many of you guys got on this type of problem last night? Oh, okay. So hopefully that helped as far as homework questions. Let's go grade homework. Section 2.3, let's start at the beginning. Oh, well, there it is. But number 14, check your division. Did you guys end up with 2x squared minus 4x plus 3? What's this whole extra thing that was showing up in homework? Domain. And why was there a domain restriction? After you divide by that guy and get this guy, what just disappeared in the division process? Denominator. The denominator was there to begin with. What was x not allowed to be since the beginning? Well, the denominator can't equal 0. So 3x minus 2 equals 0. Is that a thing? I mean, it could be a thing, right? 3x minus 2 equals 0. If it can't equal 0, then what can x not equal? Add the 2, divide the 3. Oh, they're just telling me that when I divide away the denominator, technically x wasn't allowed to be a certain guy because of the old denominator. But besides the domain restriction, these two are the exact same thing. Oh, that's nice, because which one's a lot easier to deal with, this guy or that guy? Yeah, I can find intercepts of him. I can find the vertex of him. I can do all sorts of things of him. We haven't talked about holes specifically, but technically there would be a hole at 2/3. Kyle. Well, here's the problem. If they just said use long division to divide, technically you're done. Done, 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 done. Just him. You're done. You divided. Good. But if they're asking you to rewrite the function or break down the function or simplify the function, this guy and that guy will not be the same unless you're telling me the domain restriction. What were the directions? Ah, it should be right there. What were the directions? Oh, so technically if it was just division, that would have been sufficient. But for the future, when we break down, that wasn't allowed to happen. Okay, number 30, synthetic division. Ah, they show it differently, but do you guys get the idea? This is one way to show synthetic division. My way with the little box is another alternate form. Both ways work. You get to choose which one you want. The remainder was 199. Anyone stress out a little bit about the 199? You're like, that can't be right. Huh. I thought it was weird at first. Why did they show the fraction? Yeah, that's how you show a remainder. Good. We got it? 40 and 60? 40, what were the directions? Was it just use synthetic division? Do synthetic division? Okay. Okay. Yeah. Okay. If you're using synthetic division to break down a polynomial, these are not the exact same thing unless you do x does not equal 9. So maybe that's, Kyle, where we need to be talking about this. Not so much what the directions say, but instead, if you put an equals sign, you're technically wrong if that's not there. That's a better way of putting it. Because they put the equals, they're like, oh, well, technically, only when x does not equal 9. That's a better way of putting it. So you can check your work, and if you put an equals between them, you have to write x cannot equal 9. Yeah, yeah. Number 60. They had you use, 60 was a bit more intense, because they had you do synthetic, but they had you do synthetic to rewrite the polynomial. So here's the crazy part. When you do the synthetic division with x minus 4, what factor went along with x minus, when they had you do synthetic division with x equals negative 4, what factor went along with that 0? So you divided, technically this cubic polynomial, you broke them down by saying, I'm taking out x plus 4. Okay, cool, what was left? Oh, look, I factored him just by doing a division. So this guy, you broke him down by taking out an x plus 4, seeing what was left. You could break that down just by, oh, it's a quadratic x method, I got that. You can break this guy down, but the first step, the key to be finding someone who, once you have your factors set equal to 0, dun, 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 whoosh. Does anybody know where you could have figured out the negative 4 from? Because that was the key to the whole problem, right? Was getting somebody out and getting a quadratic left. Where could the negative 4 have come from? Here? Here? Here. Don't we always look at the last number multiplied by the first and look at factors? What are factors of 48? 1, 2, 3, 4, 12, 16, 24, 48. There's a lot of them. But guess who's one of those? Guess who's another one? Guess who's another one? The factors, if it factors nicely to rational factors, found, well, there's a theorem coming for that, and that's in section 2.5. But anyway, 4, I should say, negative 4 and 6 and negative 2 are all factors of 48. Oh, those were all the evens? All right. Then, what questions do we have? Robbie. P.S. If you just got absolutely all of those right, what should you show in your homework spiral? A little check mark to be like, oh, yay, -0. Something like that, to be like, I'm amazing. And to show me that you were following along in class and weren't just being like, I can't tell the difference if you don't show me. When you just didn't. P.S. Could you guys also be grading the odds the night before when you do a problem? So some of you are like, well, I'm getting the evens all right, but you made lots of mistakes the night before. So maybe it's a good idea to grade the odds with a colored pen too, to show your brain you didn't get that right the first time. Yeah, after Calc Chat you did, but you didn't. It's not for me so much. I mean, I want to see you grading your homework, yes. It's kind of like a participation in the sense of being involved in class and being here and having your homework ready, etc. And I grade that during the homework spiral. But some of you are like, well, I'm good on even days because I've worked it all out the night before. Or maybe I just make a mistake every now and then. Well, show me that with like, hey, I'm missing 0 of the evens, but maybe some of you need to start grading your odds the night before with a colored pen. Show yourselves your weaknesses that way. Sorry, questions, odds, evens. Oh, are we good? Good? Okay, last call. I don't mind anything. Yeah, 81. 81, okay. Thanks, guys. P.S., real quick, why are you supposed to be able to access or to identify your questions really quickly, really efficiently in class? What are you supposed to do the night before if you get stuck on something? Yeah, circle it, star it, put a question mark by it so you can look through your homework. Oh, yeah, that's right, this guy. I don't know. Or if you graded the odd the night before and you were wrong, it's marked wrong, and you're like, oh, I need help on that one. Okay, number 81, here we go. Sorry, there was a little bit more of a weight than I would have liked for that homework question. But thank you for my ones that brought it up. Here we go. Directions. Simplify the rational expression by using long division or synthetic division. I'm guessing this one was just a little hard when you came to doing long division, but maybe some of you didn't know how to do synthetic division. At the end of homework, how many of you guys say, I like synthetic division better? Okay. For those of you that like synthetic division better, here's the dealio. You wanted to use it on this problem because you're like, I like it better, right? But here's the struggle. Synthetic division only works when you're dividing by x minus a, because a goes in the box. So what's the struggle with the guy I'm dividing by? He's 2x minus 3. But what's another way of writing him? Yeah, you can make it equal to 0. Remember? We just need to put the 0 in the box. So what's the 0 of 2x minus 3? So couldn't I say this is the exact same thing? So you don't necessarily, for this problem, you don't really have to think about how that's the exact same thing. But what you do need to do is, wait, for synthetic, I have to put the 0 in the box. So you could have done synthetic. You just would have had to put 3 halves in the box. And maybe some of you are like, I don't like synthetic anymore. It gets a little harder, right? Is it impossible? No, you can multiply 3 halves by 4. 4 over 2 would be 2. 2 times 3 is 6. You can keep going. Negative 2. The 2's reduce. Negative 3. Negative 2. The 2's reduce. Negative 3. You guys are lucky on this one because this one doesn't have any nasty fractions when you multiply because the 2's keep on getting reduced. But was it as nice as long division? Probably in this case. I don't think so. But if you're not too afraid of fractions, synthetic was possible. Just in case, though. Just in case some of you guys did the long division, because synthetic was definitely, I think, the trickier option in this one. You would have had to, I'm going to run out of room real fast, multiply by 2x cubed, right? No, sorry, squared to get the cubed. Remember, you distribute. We got down long division last night, right? Minus 6x squared. We didn't kill seals. How many of you killed at least one seal? Maybe you found it, maybe you didn't. Anybody kill any seals last night? Wow. Okay, hopefully that shows up on the test too. No killing of seals. I'm a fan of that. Speaking of tests, what's due on Monday? Test corrections. Negative 8 plus 6 is negative 2x squared. I'm thinking tomorrow in our group time at the beginning of class, I'm thinking I'll let you guys quickly powwow about any corrections you're stuck on. Does that sound good? Okay, just real quick. It'll be like just a couple minutes. How many times does 2x go into negative x times, right? Okay, and that would end up being negative 2x squared plus 3x, right? Don't kill any seals. Negative 2x plus 3. And then I have a negative 1. And that'd be a negative 2x and then positive 3. And when you subtract, they're the exact same, so you get a remainder of 0. Yeah, how did that happen? Ready? How could I rewrite this one?
Oh, it's 2.
Why is that true? Why is that true? When you do synthetic division, you do find the 0 and plug in. But here's the dilemma. If we're actually writing this guy out, I'm just so sad I can't make this any bigger. 4x cubed minus 8x squared plus x plus 3. If I was actually breaking him down, 2x minus 3 times what we just figured out from the long division, 2x squared minus x minus 1, is actually not. The long division gets you the perfect answer. What would the synthetic division get you? is this the exact same as that? They have the same 0. They hit in the same spot, but are they the exact same? That has a slope of 1. That has a slope of 2 as far as these linear factors. They're not the exact same. Now, they do both multiply to get that guy. But here's the struggle. You would have to factor out a 2 from this guy in order to put the 2 into that guy to get the 2x minus 3. So when you do synthetic division with the 3 halves, you do have a correct representation of the original. The struggle is you would have to take a 2 away from all of him in order to get back to your 2x minus 3. So the struggle is they weren't telling you to factor this guy. If they were telling you to factor, that guy would have been the same as that guy. They're both factors. They both technically work if you were to like polynomial multiplication, do that to these expressions. They would both work, but the struggle is that guy has a 2x minus 3. This guy doesn't, so I'd have to pull out the 2. And so ultimately, synthetic division would finally get you to your answer they were actually looking for. It just takes a little bit longer. And you would have had to have a much deeper understanding of what was really going on in the problem. So long story short, what do I think is easier if you don't have an x minus a? I think long division is probably best. But I wanted to show you how synthetic division does work. Thanks for that question, Adam and Kyle. I appreciate it. That was a tricky problem, especially if you wanted to do synthetic division and you didn't know how. Let's go ahead and go to section 2.4. I don't think you need this one. Guys, we're not going to do this problem, but maybe, just maybe you figured it out from homework. How can you use synthetic division to show that this guy is a perfect factor of that guy? Sorry, is a solution to that guy? What would happen when you do synthetic division if this does perfectly become a solution? What's going to end up right here? A 0. Anytime you do synthetic division and a remainder is 0, this is an actual solution or an actual 0 of the function, which means this is an actual factor. And we saw that in the problem that we just talked about with the negative 4, x plus 4 was a factor. If we can plug in and the remainder is 0, or if we can actually just plug in, and 16 minus 14, no, sorry, 8, thank you, minus 14 plus 6. That also shows that x minus 2 is a factor, which will be very, 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 very helpful eventually. Here we go, 2.4, complex numbers. You know what's super, super ironic? Guess who else is doing complex numbers right now? Algebra 2. Algebra 2 kids. Algebra 2 kids are doing complex numbers, which means I think actually their homework was due today. I was going to say you could almost get some tutoring hours if anybody's stuck on it. I think I just heard the air finally kick on. Took a little while. Sorry, guys. But I think I just heard the air finally kick on. Hang in there. It's going to cool down. Okay, what's the struggle with square root of negative 1, cool kids? Why is it imaginary? Because why? Why doesn't it work? Why can't you square root a negative? A negative times a negative is a positive, and a positive times a positive is a positive. Can anything square or be a negative number? Well, not except for that guy, right? What do I mean, not except for that guy? What's the square root of negative 1 times the square root of negative 1? No. Only imaginary numbers can be squared to be negatives, right? Quick reminder, who's I squared? Only imaginary numbers can be squared to be negative. No real numbers can square to be a negative. We'll get back to that in just a second. But who is this guy? Yeah, he's I. 1i is the square root of negative 1. Standard form of a complex number is a plus bi, where a is the real component and bi is the imaginary component. Put a real component together with an imaginary component, you have a complex number. If you just have an a, we could call a plus 0, I. So actually, any real number can be written as a complex number. 4 is 4 plus 0, I. Pi is pi plus 0, I. Square root of 2 is square root of 2 plus 0, I. All real numbers can be written like complex, just the imaginary part is a 0. And all imaginary numbers can be written as a complex because it would just be 0 plus bi. So quick examples of that. If I was to ask you to write as a complex number, something like, what did I say? 4. We could just do 4 plus 0, I. So any real number can be written as a complex. But what if I was to ask you to write as a complex number the square root of negative 16? What's different? How can you rewrite that as a complex number? It is complex. Square root of a negative number has to be complex. How do we rewrite it, though? You guys don't remember this from Algebra 2? How do we rewrite square root of negative 16 now that we've talked about how I is the square root of negative 1? 4i, yeah. What's the square root of 16? 4. Oh, we still have the square root of negative 1. It's okay, that's I. So it'd be 0 plus 4i. Do you see the difference? This guy, just 4. That guy, square root of negative 16. So square root of 16, 4. Oh, there's a negative 1. I. We're done. We're done. Okay. So what can we do with complex numbers? I don't know. Multiply? Wait, we're missing something. Where's adding? Okay. Whew. I was like, we jumped. I apologize. Adding and subtracting. Let's do that before we multiply and divide. Adding and subtracting. I bet you guys totally know what to do. So after you write down the quick hint, combine like terms, I want you guys to do example A, example B, or example 1, example 2. Because I bet combining like terms is all the hint, the clue that you need. I bet combining like terms is all the hint or the clue that you need. What do you guys got for number 1? Oh, is that legal? You just say 7 and 5 is 12 and 3i minus 4i is negative I? Yes, but be careful. Please, 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 please. What's the understood number in front of the parentheses? Did you guys just double check really quickly that you can just ignore the parentheses? As long as you knew it was legal, that's fine. And why am I making a big deal about that? Because down below, can I say 8 minus I? That's even worse. Can I say 8 plus I? No. Because I have to distribute the negative, right? I did kill a seal. P.S. Did any of you guys kill seals on your tests? Yeah. Gotta be careful of those parentheses. There's no judgment for killing a seal except for the fact you gotta slow down and realize it can be a struggle if you don't do your work step by step. Now, some of you still, I mean, myself included, we can do silly mistakes even with it written like this, but is it harder? Yeah, 3 minus 5, I should know that's a negative 2. Positive 4i, positive 3i, I should know that's a 7i. But can I show you what this really means? Is that okay, just real quick? Doesn't this mean 12 minus the square root of negative 1? Same thing, right? So you guys tell me, who's that guy? Does that make sense? Now, you're rarely doing that. You're rarely showing that. But I just want to make sure that you guys know where he's coming from. Oh, hey! Couldn't this have come from an x equals negative b plus or minus square root b squared minus 4ac all over 2a? Couldn't that have come from that?
Yeah.
Sure looks like it. A negative 2 doesn't have a minus, but square root of a negative. Wait, on the worksheet, we would have just said none. Wait, we're building up to 2, 5, where we're not just going to say none. We're going to say, ooh, it's a complex 0. Okay, moving on. Can we multiply complex numbers? Since we're reviewing complex anyway, we're going all the way and saying, what happens when you multiply? First of all, write it down, multiply. Multiply by distributing. Ooh, 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 ooh. I'm trying to remind you not to kill a puppy. You got to foil it. So first of all, I'm reminding you not to kill a puppy. You got to foil it. Then simplify. We'll talk about that in just a second. Simplify. Yeah, combine like terms. No big dealio. Dun, 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 dun. Uh-oh. Ready, set, foil. There's an extra step to simplify. I'm going to put a quick little note. We'll get back to it as soon as you guys foil. If you want to do mental math, I'll be okay as long as you're not killing puppies. If you want to do mental math, I'll be okay as long as you're not killing puppies. Otherwise, you better be writing this out. Just because I want to know how you guys are doing. Who mental mathed that or could mental math that? Okay. Okay. If not, no stress. No stress. Write it out. You know what it is. It's 4 plus 2i times 4 plus 2i. No stress. Do your first, outer, inner, last. And you would just have an in-between, 2 in-between steps, technically. So question, did we simplify by combining like terms? Yeah. But is that enough? No. Because we just talked about how I squared is the same thing as square root of negative 1 times square root of negative 1, which is the same thing as square root of negative 1 squared, which is the same thing as negative 1. This is real. Don't make it look imaginary, because it's not. This is real. It's going to end up being 16 plus 16i plus 4 times a negative 1, which ends up being 12. Adding a complex number plus a complex number is still a complex number. Subtracting a complex number from a complex number is still a complex number. Multiplying a complex number by a complex number is still a complex number. It's not this weird quadratic dude. He's still complex. It's kind of crazy. We would say that complex numbers are closed under multiplication, meaning it's still a complex even after you multiply. Anyway, snazzy terminology from a class way higher than this one. So, I squared equaling negative 1. Isn't there like this thing about powers of I? Let's talk about powers of I. Now, in just a second, we're going to have to figure out who is I to the 5th and who is I to the 129th. Ah! Let's start off a little bit nicer and smaller. Okay. Who's I? Who is he? Square root of negative 1. Who's I squared? Square root of negative 1 squared, which is negative 1. Who's I cubed? Square root of negative 1 cubed, which is square root of negative 1 squared times square root of negative 1. Okay, this is getting confusing. What if I just called him I times I squared. Ooh. What did we just say about I squared?
Square root of -1.
That's I times a -1, which is negative I. Oh, so I have I. Now, hold on. Notation-wise, square root of -1, I mean, that's true, but okay. So I is just I squared is -1, I cubed is negative I. What's I to the 4th? An I squared times an I squared, or a -1 times a -1. Ooh. So I simplifies to be just I. I squared can simplify to be a -1. Oh, I cubed can simplify to be negative I, and I to the 4th can simplify just to be 1. Who's the guy if I met on the street that would be the nicest to come up against? I to the 4th, because of 1. Psh, he's easy. Give me a second, Kim. So what's I to the 5th? I squared, or I to the 4th, who's the nicest out of these guys, times an extra I. What's I to the 4th? Just 1. Oh. I to the 6th is going to be the nicest guy, and how many more? Well, I to the 4th is just 1, and I squared is just -1. I to the 7th is the nicest guy, and then I cubed more, which is, oh wait, we already talked about him. That's 1 times negative I, which is just negative I. And then I to the 8th is 2I to the 4th, which is just, what do you guys notice? Every 4, it's repeated. So here's the dealio. If I wanted you guys to simplify, before we get down here, something like, I to the 18th. Before we get down to the crazy ones. I to the 18th. Do you really need to break it down? Well, I guess you could. Why did Kyle jump to 16 in his head? Because I could do 4, 8, 12, 16, and all I'm really curious about, because that's 1 and 1 and 1 and 1, I just want to know how many more. So how many past 16 is it? And that puts it in a camp. Oh, it's really just an I squared. Oh, it's -1. Because everything else is 1 times 1 times 1. So all I really care about is not so much how many I to the 4ths is in there, but how many more. What's the remainder when you divide by 4? And that'll put it in the correct camp of how to simplify. So ready, set, take I to the 35th and I to the 129th. And Kim, do you still have your question, kiddo? Can you blow your nose? Okay. There's more tissues back there. You're thinking multiples of 4. I don't really care how many multiples of 4, but multiples of 4 would only get you so high or so far. Multiples of 4 would only get you so high or so far. How many more I's are there? Just for you guys to check your logic. Why am I thinking about 8 different multiples of 4? That's 32, and how many more are there? So what's that? Really just 1 to the 8th is still just 1. Who's this guy? Negative I. Any power of I either comes back to a real number, 1 or -1, or it comes back to an imaginary number, I or negative I. Maybe some of you guys who are curious about imaginary numbers and their practical application might want to look into electricity. Why? I is sometimes real and sometimes imaginary. I should say powers of I, sometimes real, sometimes imaginary, sometimes on and sometimes off. What am I talking about? Circuits. Maybe also computer coding? Binomial, or I should say, coding, base 2, 0, 1, 0, 1, 0, 1, zeros and ones, on, off. Interesting. Maybe there's more to that. But I'll leave that for your own personal edification if you want to go check it out. I to the 129th. Anybody figure out how many 4s are in there?
32.
How many extra i's? Wait, 32, right? We're not scared of division, are we? 3, that's a 12. 0, bring down the 9. 4 into 9 is 2. How many extras are there? Just 1. Oh! He's just I. Dun, 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 dun. Okay. Anyway, we had to do this quick little like simplifying powers of I just because basically in homework, I don't think it goes too crazy high, but just reminding you that when you have i's to powers, you don't need to stay there. They do simplify. They need to simplify. But we haven't talked about dividing yet. Ugh. Dividing is, as you guys are writing, our goal for this page is to figure out, are complex numbers closed under division, aka when you divide a complex number by a complex number, is it still a complex number? Can it still be written as an a plus bi? Sure doesn't look like it. 5 over I can't be written as 0 plus bi or a number plus bi. Well, but can it?
Yes.
Polynomials are not, well, this is starting to get kind of gross. I might be misusing the notation or the word, but are polynomials closed under division? X divided by 3x squared plus 1. Is that still a polynomial? No. Because it can't be written as an ax squared plus bx plus c or any sort of polynomial. It's stuck. It's what we call a rational function. But complex numbers are super crazy in that if you divide a complex number, which is technically 5 plus 0i, by a complex number, 0 plus 1i, it's still complex. No, it's not. I can't do 5 divided by I. Well, can you rewrite them? What? 5 divided by I is really just negative 5i? AKA 0 minus 5i? AKA still a complex number? How did I do that?
You multiply by 1 creatively.
I multiplied by 1 creatively. It's totally legal. Still kept it totally balanced, meaning that value is the exact same as that value. But what did I times I do with that denominator? Ha ha! That's a little crazy if you think about it. But is it enough if I just multiply this by, oh, this is easy. Okay, times I over I, dun, 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 and I end up with 6i minus 7i squared. Sure, I'll deal with that. All over 1i minus 2i squared. Uh-oh. Who's still down there? So what's my hint over here? Just like we would do when simplifying expressions or denominators with radicals, when rationalizing, we're going to do the same thing here. Multiply by the conjugate, careful, of the denominator, not any conjugate. Conjugate means, real quick, vocab review. If you have an a plus b, we could say given. The conjugate keeps it the exact same but flips the middle inside sign alone. So I'm going to multiply by 1 plus 2i. 1 plus 2i. But I can't forget that these are binomials. Yikes. So how are we going to solve it? Boiling. And what happens when you multiply by a difference of squares? You get the first, the outer, and the inner cancel. You get the last squared with a minus in between. A minus b times a plus b is a squared minus b squared. Foiling gets you there too. But on the top, I actually have to FOIL. All right, I have a 6, then I have outer, which is plus 12i. Guys, you got this. Come on. Don't be scared of foiling. Doesn't look complex to me. Wait. What's an I squared? I can just make that a negative 1. I can make that a negative 1. And I end up with 12 minus 7 is minus 5i. Negative 14 times negative 1 is plus 14. 1, negative 4, negative 1 is plus 4. Hey, 6 plus 14 is 20. 20 minus 5a all over 5. Don't kill a kitten. Factor out of 5. Well, maybe it's easier life skill if we think about how it's going to be 20 over 5 minus 5i over 5. 4 minus... Who's easier, that guy or that guy? That guy all day long. If you divide a complex number by a complex number, guess what? With some manipulation, aka multiplying by 1 creatively with a very strategic approach, you're still going to get complex numbers. Dun, 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 dun. Section 2.4, homework due tomorrow, just in time because the bell's about to. Bye, guys.
Wow.
That was a good day. Bye, cool kids. Review your eyes. If you need help, go ask an Algebra 2 kid. Just kidding, your dividing might be harder than their homework. But I'll see you guys later. Happy Thursday.